Hello, I'm Igor and welcome to my tech farm. I have a 3D printer review for this video, and this is the Sovol SV06, and this box is sent to me by the Sovol in exchange for a review. Now I already saw the pictures, and this looks like some kind of copy of Prusa MK3S, but the bed size is similar like in the 3, so 220 and 220 on X and Y, and 250 millimeters in Z axis. Now the huge difference is the price. Of course, depend on the country, but I can see that the price is approximately $300. And if you want to compare it with the Mark 3S, in that case, well, depend. I will see how assembled is this printer. But if I want to compare to the kit, approximately 3 these printers I can buy for that price. And if I buy assembled Prusa MK3S, in that case almost 4 Sovol SV06 can be purchased for that price. A few other specifications: it has a planetary gear extruder which reduces more torque, but I couldn't find any information about the ratio, but if I got the answer from the Sovol in the meantime, you can see the ratio here. It has all metal hotend and it is able to heat up the nozzle up to 300 degrees Celsius. The bed up to 100 degrees Celsius, and I can see that on the website there is an option that we can buy it with enclosure or with a dryer, which is quite useful because let's say if we want to print I don't know, AVSA on higher temperatures, definitely an enclosure is recommended, and dryer, well, dryer is mostly recommended for PETG or nylon. It has auto leveling inductive sensor, and I hope it is faster than those partly mechanical like BL or CL Touch. It has dual Z-axis, but probably not independent, because I can see it has a 32-bit silent board, but only 4 stepper motor drivers. So both stepper motors on Z-axis share the same driver, so they cannot be independently adjusted. And it also uses TMC 2209 stepper motor drivers. They are silent. It has nice belt tensioner, and this is improvement compared to the Prusa. And it uses flex PEI sheet. This means the removing of the object is much easier. And it has the same size like NS3 printer, so you can easily buy a spare sheets. But I think probably we have to recalibrate every time the Z offset or that live Z for different thickness of the sheets. But let's see what's in the box. Everything was nicely packed and protected in this packaging. Well, it is quite pre-assembled. So here we have this X-gantry, user manuals, the older version of the screen. Here I could see some possibility for improvement. Sample filament, but I would definitely recommend to place on this some kind of cardboard spool at least, because the beginners don't know how risky it is to print from this. It may fall down from the spool, get tangled or jam or something like that. The spool holder, power cable, which is well, not correct for my country, but I have my own power cables anyway. This is the power supply unit, and definitely you should check the voltage. In US it should be switched to 115. Here in Europe it is correct at 230 volts. And this is the base with the box for the main board. This is that planetary extruder. This is that auto leveling sensor. Part cooling is from 2 sides. This is the part cooling fan. This is the hotend fan. And looks like the view to the nozzle will be blocked by the part cooling fan, similar like on Sprite extruders on the Creality. And these are the tools in the kit, so we have bolts packed for different steps. This is the small SD card with the USB reader, tools, metallic tweezers. This is very positive. I suggested so many times to manufacturers to place metallic tweezers. They are much more useful tool than the spatula. Here we have some smaller version of the scraper, zip ties, spare nozzle, and a wrench for the nozzle. Oh yes, and of course the pliers. This is completely new product, and Sovol asks for a little bit deeper review, but I have to fit in 1 week approximately, if possible. Okay, let's try. Let's analyze this X-gantry. So it uses these linear rods. I'm not too big fan of this type of the joints, because if there is any kind of eccentricity in them, in that case that will be transmitted to this lead screw and it will fight against these linear rods. So for example on Prusa, it arrives with completely permanently assembled to the stepper motor shaft. I noticed that new printers like to use this smooth alloy extrusion on one side. I don't know, I really like those grooves because we can mount different things to them, LED lights or something like that. And on the top it used some kind of injection molded plastic parts. So I would like to see here alloy extrusion too, but with grooves, so I can mount different sensors, camera or something like that on the top. What is improvement compared to the Prusa, we have this belt tensioner on X and Y axis, because on Prusa we have to do it on quite a different way by untightening these bolts and then rotate it, tighten it back, and very often I saw that users broke here this plastic part. So this is improvement, but I noticed that they use a smooth passive pulley on this side. I read somewhere that it is recommended a little bit longer lifespan of the timing belt will be if we use a geared pulley too. On Y-axis it is geared on the other side, but here it is smooth. So I think a geared pulley should be placed on this side too. And this is the base upside down. Here we have 3 linear bearings, and this is a gauge timing belt, which is good quality. And let's take a closer look of the mainboard box. So here we have the fan, probably it's cooling the stepper motor drivers. And I already saw this on the pictures on the website. It has 4 stepper motor drivers, so this means that we cannot have independent Z-axis. And positive is that I can see high current wires are crimped with ferrules. This is important from the safety reason. And this ribbon cable goes to the hotend, so it will give much nicer cable management. The mainboard type is Sovol V1.3.1, if it will be important in the future. Let's start with the step 1, which is installing the gantry to the base using these bolts from the step 1. This step is simple as it looks like on the footage, because we have to screw in these bolts from a side and not from the bottom. Step 2 is installing the display, and I noticed it is quite open from the back side, so I would recommend to place some kind of cover on it. An important part, which is not mentioned in the manual. Next, installing the power supply unit with bolts from step 2, using these 2 holes. And one more time, maybe you could check if your voltage is set correctly, and maybe some useful information. And with 2 bolts it was fixed to this frame. Next is mounting the extruder kit with these bolts from step 3. And recently I noticed that this carriage is quite loud. I mean, compared to Prusa MK3S, I'm not sure what type of the bearings they use here. But let's find out. The back plate is fixed with these 6 bolts. I cannot see any markings on them, so probably in this price range they cannot use the Misumi bearings, but at least you can see how can you replace them if necessary. And I noticed that one bolt was screwed into the plastic, so here one heated insert is missing. I'm not too big fan of this plastic carriage. I think it would be much better if it would be some kind of CNC'd aluminum, but at least it is injection molded and not 3D printed like on Prusa. And now preparing the control box installation, and the first step is to rotate this into unlock position. And now slide the box to these holders and rotate this to lock position. 2 bolts from step 4 bag, and spool holder is facing to the side where the extruder is. And now the wiring and all cables are labeled, so it is very easy. On this side I have to connect the Z1 and the X stepper motor. Y stepper motor is already connected. And on this side Z2 and the screen cable, and I cannot see limit switches, so maybe it really has the sensorless homing. According to the manual, it goes to the EXP3 and connecting the power supply. And I will use some zip ties, but a little bit bigger ones, so I can lock the position of this cable so they will not be below the leg. Same on the other side, the power cable. I got wrong power cable, but I will just use one of my own. This is from NSCV2. This screen is already familiar to me, and so far it is very quiet, but we will see later during the printing when all fans are working. Just quickly I want to try moving of the axis. And now I noticed I forget to connect the ribbon cable to the extruder. And now I can even start the first homing. Don't be surprised, before first homing you cannot move the negative values, so if this is the start position, you cannot move it more to the left, only to the right, because I think this is 0, 0 position. It's time for the leveling process, and I will just follow the instructions in user manual, and the first step is auto Z align. Now, since it have only one stepper motor drivers for both stepper motors, it cannot rotate independently with G34 code. But what can it do? It will move up and hit the top frame, and then if there is any unequal, because I can rotate independently one side, it will hit the frame and one of the motor will skip and the other will be in same level. Little bit scary process, I don't like to do it. Prusa also use this method from time to time, but definitely not too often. So it's pushing up until the Z is equal on both sides, and properly doing the homing now. Next step is the auto home, and it will be preheated to 120 degrees the nozzle and the hot bed to 60 degrees Celsius. And I can set the Z offset, so I want the nozzle to be approximately 0.2 mm from the bed surface. Okay, now I had that perfect friction between the nozzle and the paper, so distance is approximately 0.2 mm. And important is to save the settings. Store settings. And now level bed command, and it will create some kind of offset mesh and use that information during the printing to compensate any inaccuracy of the surface along the Z-axis. And this is a time lapse of approximately 2 minutes. And it's ready. Now I can load some filament, so I have to preheat the nozzle, prepare, preheat PLA. Now seriously, be very careful with this, because it may easily fall down from the spool or something like that. Definitely don't like to use this kind of sample filaments without the spool. Okay, so cut the end of the filament under 45-degree angle. It has very big ratio. I can feel that I have to rotate a lot, and it's going very slowly in. This means its small stepper motor really can provide quite enough torque. View to the nozzle is blocked, but I can see it was tested with some yellow filament. Unfortunately, they are using this micro SD card. I really like better those bigger regular SD cards. Print from media, and let's see, dog, Benchy or test code. Okay, let's see what's this. I don't know what kind of test file is this, but it prints on 175 degrees Celsius. Unfortunately, this part cooling fan is blocking the view to the nozzle. And from the side, the auto leveling sensor is blocking. From the left side, the fan shroud is blocking the view. And only from the back side I have the clear view to the nozzle, so definitely this will not be the printer for my YouTube videos showing the printings. So I'm definitely confused why is this test file on 175 degrees Celsius. I I just noticed some time. The printing is at 25% approximately, a little bit more than 1 hour. So this will be almost 4 hours printing, and I have to go to pick up my daughter from kindergarten. So I secured these filaments with this solution, and I will watch everything over this IP camera, so if there is any problem I will ask my wife to stop the printing. Printing is at 55% after 2.5 hours, and this is the picture I could monitor until I was not here. I want to measure the temperature of the stepper motors, and the hardest will be this one on the extruder. The extruder temperature is 41 degrees Celsius, and of course it's stabilized now after more than 2.5 hours of printing. Usually the Y stepper motor is the hottest. 43 degrees Celsius, X 47, Z left 39, and Z right also 39. Of course this may vary, depends on the setting, but on this printer the X stepper motor is the hottest. But not critical, just to pay attention if you place this inside the enclosure. It was printed in 5 hours and 3 minutes, and this is the amount of the filament which left on the spool, and it looks like it sticks good to the bed. I will wait until it could, or maybe... Oh, it was quite easy to remove it. Aha, this was the gap test. Okay, let's analyze this tomorrow. Well, this test printing is quite impressive. We can see great bridging, overhang, extremely big overhang, and even from the bottom it looks quite good, except maybe the last one. 0.2, 0.3 cylinders didn't fall out by default, and just minimally I can see stringing on the top of this layer. I noticed there is a Benchy in the sample code, and I will try to use these sample filaments. But interesting, who is printing on 175 degrees Celsius? Soon it will run out from the filament, and it doesn't have the filament runout sensor, so let's test the change filament function. Continue. And it works. I don't feel comfortable to print on 175. I raised to 190 degrees Celsius. Printing is finished. This is the brim. And actually it was printed in 1 hour and 14 minutes, quite fast. And it looks great. There is no stringing, the overhang came out great, but it was printed on 175 degrees Celsius, the white part, the upper part on 190 degrees Celsius. The printer arrives with a Sovol slicer which has the profile for SV06, but I want to use the Ultimaker Cura for all my printers, and that's why here I added SV01 because the 6 is not here yet. And then I just modify and copy the profiles from the Sovol Cura. And also I change the printing volumes. And pay attention to these data because they are not changed in the Sovol slicer neither, but they are important if you are printing sequentially because it contains these dimensions of the hotend, so it will not hit the already printed object. And very important is to reduce the retraction size. This is die draw extruder. And now let's print the calibration cube, which G-code I prepared in Ultimaker Cura. Printing is finished in 32 minutes, so it was not faster. It was very easy to remove it. I think I could lower a little bit the Z offset. I can see that from the first layer, and I want a little bit better layer adhesion. And now printing in spiral or vase mode with everyone dual color filaments. the gears always goes in the pairs, so I need to print another one. And I like to use these dual color filaments for testing, because I can see if the extruder will twist the filament during the printing. If not, then one color will be constantly from one side and the other from the other. You can download this from printables.com. And with die drive extruder, I always want to test TPU filaments too. And recently I did the Polymakers TPU filament review, and I want to reprint these test objects because I want to repeat the experiment with different torque. And the softest will be the TPU 90, and I will print two at a time so I can see some stringing or how the retraction works. Looks like the first layer is okay, sticks good to the bed, and only 40 degrees I use on the bed surface and 210 on the nozzle. So pay attention because it may stick sometimes too good. Interesting, there is no stringing between two objects, and if you watch my review video, you can see that I had a lot of more stringings printed on Industry V2 with the micro Swiss die drive extruder. Printing is finished and really absolutely no stringing between two objects. The layer adhesion is perfect. And now TPU 90. It's always more trickier to insert the flexible filaments. Finally I place it in, and there it is on the other side. Okay. Print setting 220 degrees Celsius on the nozzle and only 40 on the bed. Okay, this is very interesting. Absolutely no string between two objects, but when I printed this on Industry V2, I had a lot of strings during printing these objects. And only on the back side I can see some imperfection. These are seams, but otherwise great printing. Next, printing with PETG. 240 degrees Celsius on the nozzle, 70 on the bed, 50% cooling, and looks like the first layer will be okay, but at the end I will see the adhesion to the bed. It's a small boat printed in vase mode for my daughter, and I want to check the transparency of this filament. That was not a problem at all. And very transparent filament, probably you can see this on the back side. And it floats. Interesting thing I noticed, because it's transparent, that it has this line from the bed on the bottom of this object. So definitely they should use some better quality paintings on the bed. And just another object from the same material. A small cup which I use for bacterial testings. And now let's move to even higher temperature, Prusa MK3S, which I will print on 270 degrees Celsius and 100 on the bed. I hope it will be enough. This is the brim, and it looks like it sticks to the bed, but I hope there will be no significant warping because I don't use the enclosure. So far so good, there are no signs of the warping, both ends are still perfectly straight on the bed. It's a part for my phone holder in car which was broken. The bed is cooled down, now let's remove the object. That's the brim. It looks great, but even in this object I can see those lines from the bed. And only now when printing is finished I want to ventilate this room. Better than the original. And now the conclusions. Well, it is great to have this budget 3D printer which is able to print on those higher temperatures, because don't forget, with the Teflon line hot end you shouldn't go above 240 degrees Celsius because the Teflon actually touches the nozzle, and above this temperature some toxic fumes may be produced during the heating. And I apologize that I compared this with the Prusa, which is 3 or 4 times expensive printer, but with this design, basically they challenged me to. And maybe more fair comparison would be with SM Pro, which is also expensive printer than this, but it is also able to print on those higher temperatures. And here I collected some most important specifications of this printer, and you can see quickly the comparison. But back to design. For example, they don't have to copy Prusa in everything. Let's talk about this x-axis. So this part here holds the stepper motor, and on Prusa basically we have here the tightening of the timing belt. We have to loose two bolts, rotate under third, and similar. But here that's not necessary because we have great belt tensioner on the other side, which is much more comfortable to use. So this means that they could close this frame and hold the stepper motor with 4 bolts, and we would get much more rigid structure in this case. About the extruder, it is great. I'm surprised that it printed this soft TPU filaments quite good, and I have some TPU 85 very soft filament, and maybe I will do that review on this printer. I will see in near future. But it requires a little bit time to get used or practice to insert the filament, especially the softer filament, or if the bending is not in correct direction. Yes, cut it under 45-degree angle, but it does matter in which direction you will press it in, and do some practicing and remember that position, and always insert the filament in that direction. And now let's talk about the Z-axis, this dual Z-axis, because you have to pay attention to very important thing. When it's powered off, never move one of these stepper motor shafts. This is very important rule, because they are not connected with timing belt or something like that, and you may easily move out of the synchronization. And what happens there? Because you will not do the auto leveling before every print, because the auto leveling mesh is saved and it is loaded before printing, and you can save the time because there are no knobs which will be loose or something like that below this bed. Yes, it has that auto aligning Z when it hits the top frame, but that's something you will not use too often. On Prusa, for example, we have separate stepper motor drivers for each stepper motors, and before every print it does a very quick testing in 9 points, and after that it can decide if it can do with the G34 code auto-aligning the Z-axis if necessary. Here we don't have that possibility, so that's why it is important, don't move this accidentally. Probably on purpose you will not rotate this, but accidentally you have to pay attention when you press or pull out the filament, and the extruder is on the one side. So or power the extruder, so let's move it a little bit up or down, then they are powered, they will not move. Or move the hot end extruder to the middle, and in that case, well, maybe you will not move out of the synchronization two sides. Suggestion to Sovol how to solve this: for example, before every print they could also do this very quick leveling, maybe in only 4 points or something like that, and from that information the firmware can decide if the auto aligning of the Z or maybe the complete auto leveling is necessary or not. I can see space for improvements on this printer, but basically for $300 this is a great printer, and I highly recommend it. And I don't know, so far this is my experience. I'm using it only maybe 5 days, and probably, as I mentioned, I will use it a little bit more in near future. I want to test some softer filaments on it. I hope I could give you some useful information. Thank you for watching, and happy printing!